So now in this video, we'll be having a look at a full-blown example for full projectile motion. What are the different parts that can be asked, and what is the approach to solving such questions? So let's say this is the scenario that we have here. So we have this ball which is being projected at a velocity, an initial velocity of 40 meters per second. So this initial velocity of projection is 40 meters per second, and obviously being projectile motion, this is at some angle to the horizontal. So that angle in this case, let's say this is 50 degrees. So we know that based off our previous knowledge of projectile motion, it will go in a direction like this, reach some maximum height, and then it will come back down until it hits the same level again, right? This is how we know the projectile motion would be like. And we know that the idea of dealing with projectile motion is this, that we resolve the velocities into the horizontal and vertical directions. So we say this is its initial horizontal and this is its initial vertical velocity. So this one would be V, actually I should call it U because it's initial. So Ux, so this would be the component with the angle, right? This one, so it would be 40 cos 50. And then similarly the other one, which is the vertical one, would be 40 sine 50. So the initial vertical component would be 40 sine 50, right? And now you can be asked a variety of parts depending on each question. So for example, let's say the first part says that we have to find the vertical displacement, and other questions may also just call it the height at a certain time. Let's say that this is at this time, so at t equals to 2 seconds, right? What is the value of the vertical displacement at this time? So again, the entire idea of projectile motion is that you deal with both of these components of velocities individually, right? So since here we need to talk about the vertical displacement or the height, you know this is how far above its initial position it has risen. So it's very, very easy to observe that we would naturally be talking about the vertical aspect of things, right? So what do we know here? So we know that vertically its initial velocity of projection is 40 sine 50. We know that vertically the acceleration is going to be just the acceleration of free fall. So right now we are ignoring air resistance, but in a while we'll also see how the motion, how the path would look like if air resistance was not negligible. So we know the acceleration is again going to be downwards. And if we use the sign convention that upwards is positive, downwards is negative, so this would be negative 9.81. And what else do we know? So we need to find the height at time t equals to 2 seconds. So t equals to 2, and s is what we need to find. So whatever part that we had to do about projectile motion was only till here, and setting up these variables. After this basically becomes a normal question related to kinematics. So now you just need to see what equation of motion you should use given that you have u, a, and t. So the pretty basic answer, if you have a blueprint of all of those equations of motion in your head, is that this is the equation to be used. You have a as this, you have u as this, a as this, and t as this. So we just plug in the values and find s. And by doing so, the answer you get for s is 41.66. So 42 meters, correct, to 2SF. right? And since this is positive, this means that we are upwards of where we started out from, and this is pretty basic to see. At no point in our journey do we actually go below the starting point. So we must be at some position here like this. For the next part, if we are asked to find the horizontal displacement at time t equals to 4.5 seconds, for example. So now again we first need to set up the equation. Now since this is talking about the horizontal displacement, which is basically the distance traveled horizontally by the projectile, now we need to find the horizontal displacement, so it's pretty obvious that we would need to take the horizontal approach. So what's happening horizontally? So as you guys may remember, horizontally the initial velocity was that ux that we found out, which was 40 cos 50. So this is 40 cos 50. We need to find it at time t equals to 4.5 seconds. And horizontally, because there is no force horizontally, there is no acceleration either. The only acceleration which is there is the acceleration due to gravity, and that is not horizontal, that is vertical. So now again we need to find s. So again we would use the same equation, s equals to ut plus half at square. But this one is going to be even easier to work through. Because of a being 0, this entire term will also turn out to be 0. So then for no acceleration, for constant speed, basically we just need to multiply the speed by the time. So 40 cos 50 times 4.5. So this value turns out to be 115.7, or just to 2SF this will be 120 meters. Third part, if we are asked to find the vertical velocity at the time t equals to 3 seconds. So what's the vertical velocity at this time? Again, the vertical velocity means that we would have to take the vertical aspect of this projectile motion. So vertically, again, what do we know? So we know the initial velocity with which it was projected, that was 40 sine 50. And we know that vertically acceleration is negative 9.81, and we know t is 3, and we really need to find v. So now again you only need to decide which equation of motion to use, which one involves all of these. So that's the first and the most basic one, which is v equals u plus at, right? So you just substitute all your values. This is u, this is a, this is t. So then the answer for v that we get is 1.211, or just to 2SF 1.2 meters per second. Now just using the displacement values, I cannot comment on where the projectile is in its motion, but based off this I do have a pretty good idea. Because the idea is that it was initially projected with a speed 40 sine 50. If I try to find this out, this is 30.6, and the vertical velocity which I just found was 1.2. So it's a very small velocity, right? So we know that as this projectile goes along with time, its vertical velocity gets smaller, because the acceleration due to gravity downwards is going to slow it down. So it must be at some position along here where the velocity is pretty small, and it's only going to move only slightly upwards, right, until the maximum height. This is what we also know just from our approach on kinematics, the approach on equations of motion. This is nothing new. The next part, if we, for example, are supposed to find the horizontal velocity, again let's say at t equals to 3 seconds. So the idea is not at 3 or 4 or 5 or any time for that matter, for any time, it really even doesn't depend on the time, the horizontal velocity will be the same as the initial horizontal velocity, right? Because there is no acceleration horizontally. You can also think of it in this way, that you had u plus at, but since this is the horizontal aspect on things, there is no acceleration, so this is 0. So this is always going to be equal to that 40 cos 50, which by the way is 25.7, so 26 meters per second horizontally. Another very common part which is asked by the examiner is that if we would have to find the maximum height reached. So again, the idea is that for the maximum height, and height we previously referred to as vertical displacement in the very first part. So for the maximum height, we know it would be this one right here. The idea is that the vertical velocity at the maximum height must be 0. Again, it's a simple proof by contradiction, which is that if at the maximum height, if it did not have 0 vertical velocity, it was supposed to go a bit higher, right? Because it had some vertical velocity. But if it's not going any higher, this means that the velocity vertically is 0 at the maximum height. So again, we'll be taking the vertical aspect of things here again. So vertically, the final velocity v must be 0. The initial velocity must be that initial velocity of projection 40 sine 50, and we know the acceleration must be equal to negative 9.81, and we need to find the maximum height, which is s in this case. So what equation of motion do we use? Which one involves v, u, a and s? So the simple answer is this one, v square equals u square plus 2as, right? V is 0, this is u square, this is 2as. So s would be simply this 40 sine 50, whatever this is, squared divided by 2 times 9.81. When I take this there, it would also have a negative sign, so that would cancel out with the negative sign due to the acceleration, and this turns out to be 47.9, or just to 2SF, this would be 48 meters. So this is the maximum height it reaches vertically. Let's do another part where, for example, the examiner asks us find the time to reach the maximum height. So for the time to reach the maximum height, if you think about it, now I know everything that we need to know about the maximum height except the time itself. And what I mean by this is vertically again, because we're talking about the maximum height, vertically we know that the final velocity must be 0, initial velocity must be 40 sine 50, a must be negative 9.81. We've also found s as 47.9 meters, and the only thing which is now left for us to find is the fifth variable, which is time. So now just also for the sake of saving some of our time and effort, we can just go ahead and use the simplest equation involving time, because we now know v, u, a and s as well. So the easiest one is the first one, which is v equals u plus at. So from this equation we can just make t the subject here, right? So v is 0, again you shift the u here and divide by a. So 40 sine 50 divided by 9.81 is going to be our answer, which turns out to be 3.124, or just to 2SF this would be 3.1 seconds. If I now also ask what is the time of flight, which is the total time for which the projectile is in the air. So again, to answer this part as well, I can use ideas related to symmetry, which is that from the point when it's projected to when it reaches its maximum height, if that time takes 3.1 seconds, so it would also take another 3.1 seconds on the way down. So this total time of flight would basically be twice the time for the maximum height. So that would be 2 times 3.124, so 3.12. So this would turn out to be 6.24, so 6.2 seconds, correct to 2SF. Eighth part, which is the range of the projectile. So just as how we talked about the maximum height, which is the greatest distance that it goes up from this position where it started out from, the range refers to all of this distance, all of this, right? So for this we can just go ahead and use again the equation that we used above. It was maybe, it's still upwards. So the horizontal displacement, I can just go ahead and use this one, and instead of taking the time 4.5 seconds, I can then take the time for the full journey, right? So that 40 cos 50 multiplied by the time for the full journey, which we just found out. So again, S equals ut. Horizontally, let me write. So that 40 cos 50 times 6.2, and this turns out to be 160 meters. Right, so this is the entire horizontal distance, the horizontal displacement it covers throughout its entire journey. The ninth part is the displacement at time t equals to 2 seconds. So in one of the earlier parts, we found the vertical displacement at time t equals to 2 seconds. So now all we need to do is we need to find the horizontal displacement. So let me just go up and double check if it really did do this. So this is the vertical displacement at t equals to 2 seconds, which was 42. So the vertical displacement is 42. And now we need to find the horizontal displacement. So horizontally, we have t equals to 2. So again, we can just use S equals ut. So just the equation above, but instead of 6.2 as the time, we'll be using the time 2. So 40 cos 50 times 2, which turns out to be 51.4 meters. And just to avoid rounding errors, also let's use more significant figures with the vertical displacement. So this was actually 41.7 meters. So what I really have now is a right angle triangle of this sort, where I need to find this displacement, right? Displacement, so it started out from here, the object was at a position like this, and at time t equals to 2 seconds it's at a position like this. So it went like so in its journey, right? And we need to find the displacement, which is basically the shortest straight line distance between these 2 points. And now that we've found both the horizontal and the vertical displacements, I know this is going to be 51.4, right? This is an S, by the way. So this is 51.4, this is 41.7. This is a right angle because this is horizontal, this is vertical. So I need to find out S. So we can just go ahead and use Pythagoras theorem. So S squared would be 51.4 squared plus 41.7 squared. And then you would take the square root. So this turns out to be 66.2 or just 66 meters, correct to 2SF. Strictly speaking, the answer right now is not complete. We would also need to find this angle because displacement is a vector quantity, right? The angle that it makes with the horizontal. So for this case, I can just use tan. Or by the way, we can actually use any of the other ones as well because we know all the sides of the triangle. But tan is the least riskiest one to use if for some reason maybe you calculated this wrongly. So tan of this would be opposite. So opposite to this angle upon the adjacent, 51.4. So then you just take the tan inverse. So alpha would be tan inverse of this fraction, which turns out to be 39.1 degrees. 10th and the last part now is that if we need to find the velocity at t equals to 3 seconds. So again, just like the previous part, I'm not talking about either the vertical or the horizontal velocity. I'm just asking for the velocity at this time. So in one of the earlier parts, we calculated both the vertical velocity, which you can write as Vy or Vx. It's really up to you. And we calculated Vx as well. So if we just go back up there. So Vx was throughout the same, 40 cos 50, this was 26. And Vy at t equals to 3 seconds was 1.2. So 1.2 is the vertical and 26 is the horizontal. So this is 1.6 and this is 26. Actually this was 1.2. But again the idea remains the same, that we still have to make a right angle triangle like this. And we know the different dimensions of this triangle. We know that this is supposed to be 1.2, this is supposed to be 26, and we need to find the velocity. So V would be square root of 1.2 square plus 26 square under the root. So this turns out to be 26.0, so 26 meters per second. And similarly this angle, let's call this theta this time. So theta would be tan inverse 1.2 upon 26. So this turns out to be a very small angle, 2.64 degrees, that it makes with the horizontal.